Welcome to Comfort Physics classes. This is Dr. Sivakumar to tute physics in a comfort manner. Here the topic is electrostatic potential energy of dipole in a uniform electric field. Here the red line shows the uniform electric field. The electric field lines are equally spaced and acting along the same direction, hence it is called as uniform electric field. Here, without applying an electric field, the dipole will be in the vertical position. After applying an electric field, it will try to rotate from one angle to another angle. So here, work done by the external torque to rotate the dipole from an angle, let us say theta dash to theta at a constant velocity is W. Integration theta 1 to theta tau external d theta. Let us consider this as equation number 1. Okay, but one can able to assume if you are doing some amount of external work done in an opposite position to the electric field, the torque will also be same. So the same amount of work has to be done what the electric field does. So here the positive charge will experience the force in the positive x direction and negative charge will experience the force in the negative x direction. Therefore the total torque on the system is 0. But here we are going to find out what is the work done. In the system of rotation, torque will be a force component. As we discussed in our 11th standard, that the torque tau is equal to P vector cross E vector, or simply P sin theta. So replace this tau external by P sin theta. Therefore the above formula becomes W, which is equal to integration theta 1 to theta P sin theta and d theta. In the subsequent diagram, it shows the explanation for the integration. So integration of sin theta is minus cos theta. Therefore Pe minus cos theta, upper limit and lower limit theta and theta dash. Substitute the upper limit and lower limit, therefore it becomes minus Pe cos theta minus cos theta dash. On simplification, Pe cos theta dash minus cos theta. Let us consider this as equation number 3. So this work done is equal to the potential energy difference between the angular position theta and theta dash. Therefore u of theta minus u of theta dash, which is equal to delta u, which is equal to minus Pe cos theta plus Pe cos theta dash. Let us consider this as equation number 4. If the initial angle is, let us consider the initial angle is theta dash as 90 degree, then it is taken as a reference point. Therefore cos 90 is equal to 0. Therefore u of theta dash is equal to 0. Therefore the above equation becomes u is equal to minus P cos theta or minus P vector dot E vector. Let us consider this as equation number 5. This is the final equation for finding out the electrostatic potential energy of dipole in uniform electric field. But sometimes question may be framed and they may ask what is unstable and stable equilibrium. It is very simple. The potential energy is maximum when the dipole is aligned antipole, that is when theta is equal to pi, that is 180 degree to the external field. Substitute here cos 180 is minus 1, therefore u is equal to plus Pe. This is maximum energy. So any system having a maximum energy, particularly in the case of dipole, it is unstable. Any system, particularly in the case of dipole, if it is having a minimum energy, then it is called as stable equilibrium. So the potential energy is minimum provided the dipole is aligned parallel to the external field. That is when theta is equal to 0, cos 0 is 1. Therefore u is equal to minus Pe, that is minimum energy. Therefore the system will show stable equilibrium. Then the next topic is electric flux. What is called electric flux? One can simply able to explain. The number of electric field lines crossing a given area kept normal to the electric field is called electric flux. It is usually denoted by the letter phi and its unit is Newton meter square Coulomb power minus 1. Actually it is the scalar quantity. The general formula is phi is equal to E dot A, which is equal to EA cos theta. Here in the diagram A, B, C explains the electric flux with the different angles. In the first diagram shows that here we have a area and this area is placed perpendicular to the field lines. Therefore, the normal of the area is parallel to the field. Therefore, theta is equal to 0, then cos 0 is 1, therefore flux phi is equal to EA. If you are placing the area of the plane, that the plane is placed parallel, then the normal is 90 degree with the applied field. Therefore, cos 90 is 0, therefore there is no flux. Okay, like that one can able to rotate the planes with some different angle. Therefore, the general formula is phi is equal to EA cos theta. Then from the subsequent diagram, one can able to understand that for the same region or for the same plane, how many field lines are possible. Here at point A, more number of field lines are penetrating, but at point B, there are few number of electric field lines only passing through the given plane, but the plane dimensions are same, but at point A, more number of electric field lines are passing through it, and at point B, less number of electric field lines are passing through it. So it is understood that at point A, the field is maximum, that is electric flux is maximum. Okay, then the electric flux for a closed surface. Okay, these are all open surface. If you are considering as a closed surface, then the formula becomes closed integral E vector dot dA vector. So this and all we are going to discuss in the next video in the case of Gauss law. Thank you, students.